To keep a fast battleship alive requires sea room, velocity, and distance. To save a broken battleship from vanishing forever requires the exact opposite. It requires hard boundaries, a lack of depth, and nowhere to fall. On July 28, 1945, the Imperial Japanese Navy battleship Haruna met a reality that would dictate her fate for the next several years. She was pinned close to land in very shallow water near Etajima as the air war closed in. There was no clean escape route. Haruna was struck while moored, and flooding spread faster than damage control could contain. In the shallow mud off Etajima, a broken battleship could settle onto the bottom instead of disappearing into deep water. One outcome was a swift death below the surface. The other was a humiliating half-life as a stranded hulk, still visible, still in the way. Haruna ended up in the mud. This decision was not born of panic. It was a calculated response to overwhelming energy input. The final days of July 1945 brought the full weight of the United States Navy Task Force 38 against the remnants of the Japanese fleet anchored at Kure. This was not a skirmish, it was an extermination event. The Haruna, a World War I-era veteran of the Imperial Japanese Navy, was moored near the island of Etajima. She was a stationary target for waves of carrier aircraft, facing little effective fighter opposition even as the harbor erupted under heavy anti-aircraft fire. The physics of the attack were simple and brutal. A battleship is designed to absorb punishment, but it relies on watertight integrity and counter-flooding to stay upright. On this afternoon, the incoming ordnance exceeded the design limits of the hull. Post-war surveys and later tallies put the damage in the neighborhood of a dozen direct hits, with additional damaging near misses across the late July strikes. Detonations distributed across the deck and superstructure shattered watertight boundaries. Shock sprang rivets, buckled plates, and severed hydraulic lines. Near misses alongside the hull acted like depth charges, hammering the underwater protection system. The pumps were operational, but the volume of incoming water outpaced the discharge rate. The eccentric height, the geometric figure that determines stability, was collapsing. The ship began to list. In a deep ocean engagement, that level of punishment would seal the fate of the vessel. The crew would abandon ship and the hull would capsize, dragging its history to the bottom. But this was a harbor engagement. The geography was different, the bottom rose quickly, and the ship was already close to shore in very shallow water. Here is the hinge of the final hour. Shallow water doesn't just decide how a ship dies, it decides whether it can be reached afterward. In salvage terms, grounding can prevent total loss, and it can also happen without any dramatic dash for the beach. As flooding deepened the draft, Haruna simply met the harbor bottom. The keel pressed into sediment, motion died, and the vessel changed its definition from a floating warship to a bottom structure. The ship settled into the harbor floor and stayed half present, down on the bottom, heeled hard to port, with the forward end still showing above the surface. The violence of the late July attacks reportedly claimed 65 lives, a human cost that marked the end of her service as a warship. But the hull itself survived. The grounding produced a geometric paradox. Flooding and machinery pulled the stern down into the soft bottom first, while trapped air forward kept the bow from following. The ship locked into a steep, awkward angle, the forward end conspicuously elevated toward the sky. The result was a surreal modification of the skyline. The forward end of the battleship rose out of the water and loomed over the harbor, an exposed mass of armor and framing that made the shoreline feel suddenly smaller. Most shipwrecks are defined by their concealment. They disappear beneath the surface, hiding their damage in the dark, accessible only to divers who understand the dangers of nitrogen and depth. The wreck of the Haruna broke this rule. She did not hide. She became a monument to the violence of her own end, visible to anyone standing on the shore of Etajima. The vessel settled into a posture that defied the standard geometry of a sinking ship. Usually, a hull that loses buoyancy will either slip beneath the waves on an even keel or capsize into open water. Haruna did neither. She settled in shallow water at a stubborn list, trapped between the surface and the bottom. This abnormal orientation was driven by uneven flooding in very shallow water. As compartments flooded aft, the center of gravity shifted toward the damaged stern. The stern sank first until it met the harbor floor. But forward compartments still held trapped air, and the shallow bottom constrained the hull's motion. The ship settled into a fixed, awkward angle that did not easily change. The bow climbed out of the harbor and stayed there, improbably high, as if the ship had been caught mid-rise. It hung over the water in a long, rigid tilt, too big to ignore, too damaged to move. This was not a temporary instability. Friction and suction at the mudline arrested the movement. The list to port was severe, but the structure was static, grounded hard, fixed in place. For the locals operating small ferries and fishing boats in the harbor, the wreck became an unavoidable landmark. The most striking feature of this steel island was the camouflage. In photographs taken after the sinking, branches and tree limbs were mounted across the exposed structure as a last-ditch attempt to break up the outline. Some surfaces also appear to show irregular striping and patchwork paint, patterns meant for concealment that now sat in full view. The guns were silent, trained fore and aft in their travel locks or slumped by gravity, but the camouflage remained as a visual signature of a war already ending. The position of the wreck dictated the future of the salvage operation. Because the bow was elevated 30 feet in the air, the forward decks were dry. Engineers did not need diving bells or pressurized habitats to access the forward superstructure. They could simply row a boat to the side of the hull and climb a ladder. The buoyancy pivot had done the hardest part of the work for them. It had presented the steel on a platter. The stern, however, told a different story. It was submerged in the opaque water of the harbor, buried in silt. Any work aft of the midships line would require a different approach. But the immediate reality was clear. The Haruna was not a navigation hazard in the traditional sense of a submerged rock. She was a wall. She blocked the use of the harbor for deep draft traffic, and her sheer size meant she could not be ignored. The shallow grounding had saved the hull from the crushing pressure of the deep ocean, but it created a massive civil engineering problem. In the devastated post-war harbor, salvage capacity was limited and priorities were chaotic. What followed was not a single clean refloat in one piece, but a pragmatic process of salvage and scrapping that reduced Haruna over time, much of it carried out right there in the harbor. In 1946, the distinction between a battleship and a mineral deposit is merely a matter of paperwork. When the war ended, the Imperial Japanese Navy ceased to exist as a fighting force, and its surviving hulls were instantly demoted from sovereign territory to industrial assets. The Haruna was no longer a weapon. She was 30,000 tons of high-grade pre-war steel sitting in a country that had been bombed back to the pre-industrial age. The reconstruction of the nation required raw materials that simply did not exist. The mines were idle and imports were frozen. The only available source of high-quality metal was the fleet itself. The wreckage off Etajima was not just a navigation hazard. It was a gold mine of iron and copper waiting to be harvested. The contract to remove Haruna was taken on by a Japanese salvage firm under post-war authorities overseeing the disposal of former naval assets. The challenge facing the engineers was one of logistics and physics. In a fully functioning harbor, a team might attempt major lifts and dry dock work. At Kure, equipment and capacity were constrained, so the plan favored dismantling and removal in stages. This constraint forced the adoption of a specific salvage mode known as in-situ dismantling. This is the industrial equivalent of eating an elephant where it falls. Instead of moving the ship to the scrapyard, the engineers moved the scrapyard to the ship. The plan was to cut the vessel down vertically, layer by layer, until nothing remained above the waterline. The operation began not with heavy machinery, but with manual labor and gas torches. Work crews ferried out to the wreck in small wooden boats, climbing the listing hull like mountaineers scaling a steel cliff. They set up their equipment on the angled deck, securing gas cylinders and hoses against a steep list. The primary tool of this phase was the oxygen acetylene torch. The process was brutal and simple. Teams of cutters started at the highest point of the structure, the pagoda mast, and began to slice it into manageable sections. As each section was severed, it was lowered onto barges using small portable winches rigged to the ship's own superstructure. This method transformed the wreck into a self-consuming machine. The steel removed from the top was sold to fund the removal of the steel below it. The tiger stripe camouflage that had marked the ship as a warrior was burned away by the cutting flames, replaced by the orange rust of exposed iron and the black scorch marks of the torches. The geometry of the wreck, specifically the buoyancy pivot that held the bow out of the water, provided a massive advantage during this initial phase. The forward third of the ship was dry. The cutters could access the forward turrets, the bridge structure, and the foredeck without needing to seal compartments or pump water. They were working in the open air, stripping the armor plating from the gun houses and cutting the heavy barrel tubes into scrap segments. The salvage team utilized the ship as its own infrastructure. They built walkways across the slanted deck and used the hollow spaces of the superstructure as temporary workshops. The wreck acted as a breakwater, calming the sea on its lee side, which allowed the transport barges to moor safely against the hull while loading. By the end of the first year, the silhouette of the Haruna had changed legally and physically. The towering pagoda mast was gone. The massive gun barrels were gone. The ship was being erased from the sky down to the sea. But the easy work was finishing. As the weight of the superstructure was removed, the center of gravity shifted again. The engineers were approaching the waterline, and soon they would have to cross the boundary between the air and the sea. The steel above was clean, the steel below was filled with oil, mud, and explosives. The cutting flame burns hot enough to turn a sealed pocket of bunker oil into a trap. When it bites through a bulkhead and finds fuel and vapor on the other side, the result isn't a clean separation, it's an immediate, violent deflagration. As the salvage crews descended from the superstructure into the hull of the Haruna, they left the safety of the open air and entered a confined industrial trap. The primary adversary was no longer the weight of the steel, but the residue of the war. The ship had not gone down quietly. She had been hammered by multiple direct hits. In the chaos of the sinking, there was no time to vent fuel lines or offload ammunition. The magazines were flooded, but the propellant charges remained. The fuel bunkers were ruptured, coating the interior compartments in a thick, toxic layer of heavy oil. Every cut was a gamble. The salvage workers were operating in a maze of twisted steel where ventilation was non-existent. A single spark could ignite the volatile fumes accumulating in the overhead spaces. To mitigate this, crews had to steam clean compartments or manually scrape the oil from the plating before the torches could be lit. It was slow, suffocating work performed in the heat of the Japanese summer. Then there was the ordnance. The numbers were debated after the war, but the internal damage path of each weapon was still a mystery buried under mud and water. Unexploded ordnance, or duds, are a statistical reality of any bombardment. The cutters had to treat every deformed plate and every pile of debris as a potential bomb casing. They were dismantling a crime scene that was still armed. The physics of the operation also shifted. In the previous phase, the in-situ dismantling of the superstructure had removed thousands of tons of top weight. According to the laws of buoyancy, this should have caused the hull to rise, freeing the stern from the mud. But the Haruna was held fast by the suction of the harbor floor. The stern did not float free. The wreck remained stubbornly at its 30-degree list, forcing the workers to cut closer and closer to the water level. The hull acted like a barrier. It calmed the water along its lee side and made barge work possible, but it also penned in the runoff from the cutting and stripping. The water inside the hull was a black slurry of oil, ash, and rust. To access the lower decks, the engineers had to utilize pumps to lower the internal water level, fighting the leaks that had sunk the ship in the first place. This was the breaking point of the operation. The easy revenue from the clean armor plate was gone. Now the company was spending time and money to extract steel from a dirty, dangerous hole. The risk-to-reward ratio was thinning. Yet, they could not stop. The hull plates of the lower decks contained the thickest, most valuable steel in the ship. To abandon the wreck now would be to leave the job half-finished and the investment unrecovered. They had to cut through the danger to reach the payoff. In every large-scale recovery operation, there is a specific moment where the engineer must wield the trade-off knife. This is the decision point where the risk of the next cut outweighs the value of the metal. In a standard commercial scrapping job, the knife usually falls when the hull disappears beneath the surface. The cost of underwater work, the diving teams, the cofferdams, and the slow pace of hydraulic cutting destroys the profit margin. Typically, the bottom 10% of a wreck is abandoned to the silt because it is simply too expensive to recover. But the erasure of the Haruna was not governed by standard commercial logic. It was driven by a force known as scrap economics. This concept defines the viability of a project based on the hunger of the market rather than the difficulty of the task. In the late 1940s, the Japanese archipelago was in a state of desperate material starvation. The strategic bombing campaign had flattened the industrial cities, and the suspension of imports meant that new steel could not be bought. It had to be harvested. The Haruna was no longer viewed as a defeated warship. To post-war officials and the salvage company, she was material, valuable metal sitting in convenient, shallow water. The ship contained thousands of tons of nickel-steel armor plate and high-tensile structural ribs, materials that the damaged post-war foundries could not easily reproduce. The value of this specific metallurgy distorted the usual trade-off. It justified a depth of extraction that would have been financial suicide in a stable economy. Because of this intense economic pressure, the salvage teams did not stop at the waterline. Once the in-situ dismantling of the superstructure was complete, they chased the hull down into the mud. They used temporary barriers, pumping, and incremental lifting to keep sections accessible as the work pushed down toward the mud. Inside these damp, muddy spaces, workers cut the ship apart from the inside out, fighting the suction of the sediment to extract the double bottom. The timeline of this consumption was relentless. By 1948, the iconic silhouette that had dominated the Kure coastline was gone. The sky bow that had risen 30 feet into the air had been sliced into manageable sections and lowered onto barges. The camouflage-painted turrets had been melted down. The wreck, which had once served as a breakwater for the local fishing fleet, was reduced to a jagged ring of steel stumps, barely breaking the surface at low tide. The final phase of the operation was a war of attrition against the seabed. The crews spent 2 years pulling the keel structure out of the clay. They dredged the area to recover debris from the air attacks, ensuring that the harbor was cleared of both obstruction and ordnance. It was a slow, grinding conclusion to a violent life. By the late 1940s, the water off Etajima was empty. The battleship's visible evidence had been erased, and the 30,000 tons of displacement had been transmuted into the foundation of recovery. The steel that had been forged to fight a war across the Pacific was now the rebar in a new office building, the girder in a bridge, and the rail of a commuter train. The Haruna had not simply been removed. She had been recycled into the future of the nation that built her. For several years, the wreck of the Haruna defined the horizon line of Kure Harbor. Most naval casualties are instantaneous events. A ship explodes, capsizes, and vanishes in a matter of minutes. But Haruna lingered, dead, yet still there for anyone on shore to see. In a later account, Corporal Eugene Mercier, stationed in the region during the occupation, described the slow erasure of the battleship. To observers on the shore, the ship felt like a permanent fixture. Small craft passed near the exposed bow, and the fading camouflage and foliage remained a constant reminder of the war that had just ended. The wreck was not a rumor or a coordinate on a chart. It was a massive, physical reality in shallow water off Etajima. This extended period of visibility creates a unique legacy. Unlike the deep water wrecks of the Pacific, which are frozen in time and hidden in darkness, the Haruna was dismantled in the light of day. The local population watched the ship shrink. They saw the pagoda mast disappear. They saw the guns removed. They watched the hull get lower and lower until the water finally reclaimed the view. Today, the location off Etajima is quiet. The water is empty. There is no buoy marking the grave, and there is no twisted metal reaching for the surface. If a diver were to descend at the coordinates where the wreck once lay, they would likely find little beyond scattered fragments and disturbed seabed. Small reminders of a ship that was cut apart and carried away. The absence of a wreck is the ultimate proof of the salvage operation's success. A surviving wreck indicates a failure to recover value. A clean seabed indicates that the asset was fully utilized. The steel that once formed the hull of the fast battleship did not rust into uselessness. It was cut, melted, and reforged. The legacy of the Haruna is not found in a museum or a memorial site. It is found in the infrastructure of modern Japan. The scrap economics of the post-war era dictated that the sword be beaten into the plowshare literally. The high-tensile steel of the armor belt, once designed to stop 14-inch shells, became the structural girders for the bridges and railways of the Reconstruction. The ship ceased to exist as a discrete object by the late 1940s. But the material that composed her is still present, woven into the cities that rose from the ashes. She was the last battleship of the Kyoichiro class to disappear, and her final service was not in combat but in supply. She provided the raw iron for the peace that followed. The sea has reclaimed the space 300 yards offshore, but the ship herself is everywhere.